Okay, in problem 8.16 of our book, we're given information about people getting on an elevator, and basically we want to know if 16 people in an elevator will upset the weight limit of the elevator. And there's a lot of information in the problem before you get to parts A, B, C, and D, so let's take a look at that information. First of all, we're given information about adult weights, and we're told that the mean weight of people is 150 pounds, and the standard deviation is 27, and it's normally distributed. So I'm going to go ahead and summarize it using our notation. And it's important to note that these numbers relate to individuals. When we see the numbers 150 and 27 as a standard deviation, these numbers would be helpful if we wanted to find the probability that an individual exceeded a certain weight, or that an individual was less than a certain weight. But this problem really isn't about individuals, it's about 16 people getting on an elevator. So I need to consider what happens when we have 16 people getting in an elevator and how that's distributed. And we know that from our rules that we learned last week, that for 16 people, we need to consider the sampling distribution of the mean weights of those 16 people. So we're no longer worried about what x is, we're worried about what x bar is. And we know that if x bar is the mean weight of 16 adults, that since the population is approximately normal, the sampling distribution will also be approximately normal. The mean of the sampling distribution is 150 because it's the same as the mean of the population. But the thing that's goofy here is the standard deviation. The standard deviation will not be the same. When we have groups of anything, no matter what size, when we average them together, their variation will be much smaller than the population. And we have a formula for that in Chapter 8, and the formula is that the standard deviation of the sampling distribution is just the standard deviation of the population divided by the square root of n. So here we have 27 divided by root 16, and we find that the standard deviation of our sampling distribution is 6.75. So a lot of stuff going on here. So now we're all set to answers part A and B. So we have the distribution of groups of 16. We know that groups of 16 will be normally distributed with a mean of 150 and a standard deviation of 6.75. And those two numbers answer parts A and B. In part A, it says, what is the expected value? The expected value is just the mean. It's a fancy term for the mean. So the mean of the sampling distribution is 150. And the standard deviation of the sampling distribution is 6.75. And again, that formula, sigma over root n, the standard deviation over root n, is one of the landmarks in chapter 8. So you need to make sure you're comfortable with it. Okay, so we're ready to move on now. So in part C, we need to know about, in total, will these people upset the weight limit of the elevator, which is 2,500 pounds. Well, we have 2,500 pound weight limit, and we have 16 people getting in the elevator. So part C is really just a simple division problem. So if the weight limit is 2,500 pounds, we're really just interested in what happens, when will our x bar be greater than 2,500 divided by 16? So really our trouble number is 156.25. When our group has a mean weight of greater than 156.25, we might be in trouble because that would mean that collectively we are exceeding the weight limit of this elevator. So we're starting to put it all together now, and again we have our distribution. Really in part D, this problem comes down to what is the probability that the mean weight of the people in our elevator exceeds 156.25. So taking all of this stuff and putting it together, now this just becomes a normal distribution problem from last week. We know that the first step really whenever we have a normal distribution problem is to draw a little rough sketch of it. We have our mean of 150, and I want to know when we exceed 156.25. Now before I even go to my calculator, keep in mind 156.25, that's less than one standard deviation away. So this is something that's somewhat probable. So I'm going to guess that it's not going to be a small percentage here. But we are going to go to our calculator. We're just going to use norm CDF. In norm CDF, we want to go from 156.25 up to infinity with a mean of 150 and a standard deviation of 6.75, and we find that has a probability of 0.1772. So this problem, honestly, if you can do this problem from beginning to end, I would say you're in good shape for Chapter 8, and it really ties together a lot of different concepts that we've learned so far in the course.